This is AP Calculus BC, Unit 4, Objective 4. We're doing more volumes of rotation or revolution. The last set of notes we were focusing on rectangles that were specifically perpendicular to the axis of rotation. But sometimes we really need the rectangles to be either vertical or horizontal, and yet that's not working out to be perpendicular to the axis of rotation. So because of that, we're able to figure out another way to do it. Now the perpendicular method, that's the disc or washer method. The washer method is a little bit more generalized, I guess. So when you have a hole in the middle of the solid, don't forget that it's the definite integral from a to b of pi times big R squared minus little r squared with respect to x or with respect to y, whichever way you need it to be. Now, sometimes we will need the rectangles, as I said, to either be either to be vertical or horizontal, and that might be when they are actually parallel to the axis of symmetry. So when the rectangles are parallel, we can still generate the volume of that solid. Now I'm not actually deriving the formula here for you, but it is, and this is, I think, the easiest way to remember it. We've got 2 pi times the radius, and the radius is going to be a variable, by the way. So the definite integral from a to b of 2 pi times the radius times the area of the sample rectangle. Now within the sample rectangle, you're going to have either delta x or delta y, which in calculus becomes either the dx or the dy. So it just all depends on whether you're dealing with horizontal rectangles or vertical rectangles. So anyway, let's go ahead and try the first one here. Find the volume of a solid formed by the area bounded by y equals 3 minus x, so the line y equals 3 minus x, and y equals 3x minus x squared. That is rotated about the x-axis. Okay, so going about the x-axis, and now we're trying to do this the easy way, and so just because we have a new method, that doesn't mean that we have to use the new method. We want to do it a nice way. So for example, even if I were to look at horizontal rectangles here that would be parallel to the axis of rotation. Down here where I drew it in, the right side is on the parabola, left side's on the line. But up here, right side's still on the parabola, but the left side's on the parabola as well. So we really would not want to have horizontal rectangles for this region. So because of that, we do want to have vertical rectangles. And so really this one is in particular, it's a review of the washer method here. Notice that the rectangle is not touching the axis of rotation the entire time. In fact, it doesn't even have to touch the axis of rotation at all. It does touch it just at the point 3, 0. But because of that, then we've got the big R and the little r. And so hopefully we're recognizing the big R and the little r at this point. And so the little r is from the axis of rotation to the near side of the rectangle, and the big R is from the axis of rotation to the far side of the rectangle. And so keeping that in mind, now the rectangle itself, now it's little delta x's, because vertical rectangles are little delta x's, so everything's in terms of x's. So the top part of the rectangle is x, comma, the parabola, so 3x minus x squared and the bottom side of the rectangle is x comma the line, and the line is 3 minus x. Okay, now I like to line up a dot on the axis of rotation and label that as well, so x comma 0. Okay, why do I like to do that? Because then I can get my r, my little r and my big R better, because top minus bottom and all that. So volume, okay, now x's, everything's in terms of x's. So, and pi, and it goes from 1 to 3. And my big R is top minus bottom, so 3x minus x squared minus 0. Big R squared minus the little r. Now my little r is from the near side of the rectangle to the axis of rotation, so 3 minus x minus 0 squared dx. So pi big R squared minus little r squared with respect to x in this case, and it's the definite integral from 1 to 3. Okay, so now at this point, I mean, really this is a review problem, and unless it specifically says you get to use no calculator, I mean, you have to do this without calculator, and so this would involve some algebra, and so you do have 9x squared, and let's see, minus 3x cubed minus another 3x cubed, and plus x to the 4th, minus, let's see, 9 minus 6x squared, no, sorry, not squared, just minus 6x and plus x squared, and so we have pi 1 to 3, and if we distribute the negative and combine like terms, let's see, we do have x to the 4th, we do have minus 6x to the 3rd, I do have a 9x squared minus x squared, so plus 8x squared, I do have a minus a negative 6x, so plus 6x, and I do have a minus 9 with respect to x. Okay, and so, okay, so like I said, if it doesn't tell you you can use a graphing calculator, then you have to go through and do it. Maybe you're using a calculator just to crunch a little bit of numbers. If this one would be getting a little bit out of hand. But anyway, you can go ahead and work this one out, and this one would be 56 pi over 15. Now, by the way, notice that that's reduced. That's the exact answer. If you were to plug it into your calculator, then you would include the pi in there, and 3 decimal place accuracy would be approximately 11.729. Okay, but wouldn't expect to see that unless you actually got to use a graphing calculator. Okay, now same region. We're going to go about the y-axis this time. Okay, so going about the y-axis. Now it's the same region. We really don't want horizontal rectangles here. Horizontal rectangles are not a good situation for us. Now, the rectangles are still vertical rectangles, so everything's still in terms of x's because we got little delta x's. So it's still x comma 3x minus x squared, and also x comma 3 minus x. Okay, now, first off, what's my radius? Okay, let's start with that because we've got 2 pi times the radius. Radius is always from the axis of rotation to the rectangle. Now, because the rectangle is of delta x thickness, and we're taking the limit as delta x goes to 0, there's no like near side of the rectangle and far side of the rectangle. So the radius is just simply this distance right here. And so it's a horizontal distance, so we want to do right side minus left side. Those are x values. So x minus 0. So my radius is x minus 0, which is x. Okay, so my volume 2 pi. Now a to b, again, it's everything's x's. So it goes from 1 to 3 still. And my radius, we just figured that out, that's x. And then, okay, now my area of my rectangle. My area of my rectangle is base times height. My base is delta x, it's going to become the dx. My height, top minus bottom, make sure you're getting a positive value. So 3x minus x squared top minus the bottom, 3 minus x. And then the delta x becomes dx. Okay, so we clean it up. And let's see, I'd have negative x squared. I have 3x minus a negative x, so plus 4x minus 3. You would want to go ahead and distribute the negative. Negative x cubed plus 4x squared minus 3x with respect to x. Okay, so now, it's like if you're not allowed a graphing calculator, which that's what the homework is typically, and it's probably a little bit more reasonable than some of these problems. But anyway, you go through and you do it without graphing calculator, and definitely we should be able to do this, but I don't want to make the notes too long here. So dot, 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 if we work that out, you do get 16 pi over 3. Okay, so there's that one. Now, we don't always just rotate about the x-axis or y-axis, although those are probably the two most common lines that we rotate around. We can also rotate around other lines. So perhaps we rotate around the line x equals 3. Now, it's really extremely sad when I have a calculus student who messes up the line x equals 3 or y equals some line or something like that. And by the way, it's either going to be a vertical line or a horizontal line. So the line x equals 3, you have to recognize what kind of line it is. And this one's a vertical line, although mine doesn't appear to be too vertical. Let me try again. And I'm going to go around the line x equals 3. Okay. Now my rectangle, because it's the same region, we want vertical rectangles. There's no way we're going to do anything except vertical rectangles. So x comma 3 minus x and x comma, let's see what's the top, 3x minus x squared. Okay, now my radius is always from the axis of rotation to the rectangle. So here's my radius. I meant for that to be a different color, sorry. And so the right side minus the left side, my radius is right side 3 minus the left side x, and 3 minus x does not simplify. So there's my radius. Remember what I said, the radius is going on the shell method, the radius is going to be a variable of some sort. So volume 2 pi, and the limits of integration still go from 1 to 3 because the rectangles move from small to big in that region, and they're x's, so 1 to 3. And my radius is 3 minus x, we just figured it out. And now the area of the rectangle. Now it's the same area of the rectangle as we just did on the last one. So let's kind of skip past all that and let's go straight to the negative x squared plus 4x minus 3, and then delta x, which is dx. Okay, and again, to be able to integrate this one, you'd really actually have to multiply this one out. I'm doing some good sample problems here. They're not necessarily good sample problems for no calculator, because these would be just kind of a bear to work out without a calculator. But anyway, if you continue on and you multiply it out and you work it all the way out, we get 2 pi times, and now the definite interval from 1 to 3 turns out to be just 4/3. And so we get 8 pi over 3. Okay? Now, I have a question for you here. So, look at the last two problems, because we're rotating the same region. So, the region itself is the exact same area. And we're rotating it about vertical lines both times. Okay? Now, part B, we rotated around the y-axis, and the volume was double the volume we just got right there. Why? Why is the volume bigger for part B than it is for part C? I'll write that out. Why is volume bigger in part B than part C? Okay, now the reason why is because part B, the region is further from the axis of rotation. So if you have the same size region and it's closer to the axis of rotation as opposed to another one where it's further from the axis of rotation, the one that's further from the axis of rotation will always generate a larger volume. The one that is closer to the axis of rotation will always generate a smaller volume. Okay, so keep that in mind. That's kind of a good thing to understand and be able to deal with. Okay, so finally, a different region. This is the last problem here. Find the volume of a solid formed by the area bounded by x equals y squared and x equals 4. Okay, now looking at the equations, I'm thinking maybe I want to do horizontal rectangles, but again, let's kind of take a look at the whole thing. And is rotated about the line x equals -1. Okay, so first off, again, let's get the line x equals -1 correct. So the line x equals -1. Okay, and we're going about that line x equals -1. Okay, well, tell you what, we just did the shell method on each of the last two problems, and we only have one problem where we were perpendicular. I don't know, I mean, which way do you want to do it? The equations themselves are setting us up more for horizontal rectangle. Let's go ahead and do it with horizontal rectangle. Okay. So horizontal rectangle. So this end is 4, comma, y. This end is, let's see, x is y squared. So y squared, comma, y. And when I have the perpendicular ones, I like to put a point there. And this point right here is -1, comma, y. Okay, so my small r is right here. My big R is right here. So my big R is right side minus left side, so x value, so 4 minus a -1, which is 5. Okay, and then my little r is right side minus left side, so y squared minus a -1, which is y squared plus 1. Okay, so my volume, pi. Okay, now everything's in terms of y's now. So lowest elevation, -2, to the highest elevation, 2, pi. big R squared. Okay, so my big R is 5. 5 squared, obviously it's 25, but we're setting it up right now, so I'll just leave it that way. And minus the little r squared dy, because we're doing horizontal rectangles. Now, notice the symmetry though. Okay, if I just kind of do the top half and double it, that's a nice thing to recognize. And so if I double it, I would get 2 pi 0 to 2, and let's see, we would have 25 minus, let's see, I would have y to the 4th plus 2y squared plus 1 dy, and 2 pi 0 to 2, let's see, I would have negative y to the 4th minus 2y squared minus 1 plus 25, so plus 24 dy, and so we have 2 pi negative 1/5 y to the 5th minus 2/3 y to the 3rd plus 24y from 0 to 2, so 2 pi, and let's see, plugging in 2's, I get negative 32/5, and plugging in the 2 here, I get 8 times the negative 2/3, so negative 16/3, and plugging in the 2 here, I get plus 48, and if I plug in zeros, I get all zeros. So see, this one's actually very much a test type problem as far as not too horrible without a graphing calculator kind of thing. Common denominator be 15. I mean, that's a little bit tough, but you know, sometimes we're going to be able to deal with that. So 2 pi. So let's see, I'd have to multiply by 3 on this one, so negative 96/15. I have to multiply this one by 5, so negative 80/15 plus, okay, so I need to multiply by 15. Well, let's multiply by 10, 480, and multiply by 5. So 480 plus 240, 480 plus 240, that's 720 over 15. And so 720, let's see, minus 96. And let's see, so 720 minus 100, that'd be 620. So it's 624 minus 80, 624, so 544. So 2 pi times 544 over 15, which is 1088 pi over 15. Just in case you were worried that I'm getting out of practice, there I showed you that we can do it without a calculator. So, okay, so that is the end of the notes.